Okay, welcome to the next week of Math E. This is where we're done with what's for most people review. It's going to be different from student to student, but we're now assuming that if you're a typical Math E student, then anything starting now, you've had limited exposure to, if any. So I'm going to slow down. On the other hand, we're trying to catch up from having missed a week with the ice storm. So the solution is to not go quite as deep. That to do well on the GED, you don't need to see all the special cases of what this might look like. I'm going to introduce things with breadth, but not go quite as deep. And for depth, that will somewhat fall onto your shoulders of doing homework, because I can't make up the missed class time. But if you were really serious about the GED, you could spend a little bit of that. So we will see. At the end of today, we'll kind of check in and see how we went. We're trying to do a all together group quiz, partly to practice cooperating between the Zoomies and the Roomies, and partly because I want to see how you put work on paper. So all of that. And what's the So to summarize, if I look at what students see, we have our welcome and syllabus book. We did the week 1 and 3 and the week 3 of the review materials, and now we're on dealing with 2 linear equations at once. If you haven't done enough homework for the first 2 math topics, then catch up when you can. But they're not exactly something you need for this new topic. So we're just going to start here. No one shouted earlier when I asked, I have questions about homework. So tough movies on you if you didn't tell me, but I just move on. As always, in the book, this set of pages for this topic, there's 5 different things. You have the textbook sections for the good textbook, or the free one and the better one. Videos, we'll put our recorded videos up at the top, and they've gone through and found all sorts of stuff in YouTube, so you don't have to waste your time finding YouTube videos. We have a whiteboard that I am going to go ahead and put this link in chat as we're looking at it, so that you don't have to come into the Moodle needlessly. And open it myself. I haven't found any review to doodle topics, those old style whiteboards that will go well with this topic, but here's the page in case we find any. We'll see what happens. And then the My Open Math. Let you do your homework. So let's start by looking at the whiteboard and see what's happening. As always, it tells you at the top of all of those pages what we're doing. And part of leaving the review weeks in our past is that this is a little bit more organized than it was before. We're not seeing this giant salad bar of topics like people are going to be. So that's pretty good. Okay, so join me on the whiteboard. And then start there. If there's anyone that is new and hasn't gotten the link to do this, then here in chat is the link to be part of the whiteboard crew. For now, I want to just use the number line and say Figure. What happens? Both of these things are true. Is that big enough font over here with x greater than 2 and x less than 7? Or if that's smaller. Okay, somebody grab my blue and green arrows and mark those two things, x greater than 2 and x less than 7. Looks like this. Smart right here. Go ahead and put them right on the number line. They don't have to float above.
It's so frustrating because I just bought like a wireless mouse for this whole laptop and I forgot it.
Try and tap and then slide instead of just
See now it wants me to like type in the center.
I'll let someone else do it if it's frustrating. Okay, there we go. That's really ugly. I happened to pick numbers that are the same size as the arrows. I should not have done that. Why don't I stretch out these arrows? Okay, now they're better. Okay, so you can see where the area overlaps. I can say that, hey, this area right here is in both arrows. It is bigger than 2 and less than 7. Everyone happy with that?
Yeah.
If you're in Zoom, like put a thumbs up emote or say hi or something, so I know you're there and awake. Okay. We're doing the same thing, but with graphing. We're trying to find out where the overlap happens, because that's when two things are true at the same time. It's not any more complicated than what we just did with this number line. This is where truth is happening twice. Bigger than true, 2 is true, less than 7 is true. But it looks different on the graph, so don't be upset at that. Okay, so I'm gonna scroll down a little. And how would we do this on a graph? I'm going to say here is a green line. Here is a blue line. And what are the ways that these lines could overlap?
like just in general off of
Yeah.
on the line.
Well, what different cases could we have?
It can be perpendicular.
They could be, okay, so I'm gonna take this one and say, so now blue is there and green is there, and they overlap at that point. Everyone happy with that example?
Yeah.
Okay, what happens if they are not exactly perpendicular? Their angles don't match as well. How many places do they cross?
Still only one.
Still only one. And hopefully, since we like whole numbers, then they're going to cross at a whole number kind of place and not a fraction kind of place. And we can say, that point is where they cross, 2, 3.
What would it look like if it did cross at a fraction type?
Then I just have a more annoying time trying to figure out where visually, which is a great segue. So here, what exactly is that spot? I'm not quite sure. I know it is bigger than 3 and less than 4 for the x. It's 3 point something. And for the y coordinate, it's going up 2, it's 2 point something. Don't ever write 2 point something like that, by the way, you'll get in trouble. But I'm not sure exactly what those decimal points are. we'll talk more about this in a moment. Everyone okay so far?
Yeah.
Okay, so what else could we do? You could have them cross and have one point where they cross. How about how we started? If they're parallel, where's the overlap?
There is
Overlap.
There isn't any. So if you ever have two parallel lines, whether they're nice horizontal ones like this or at some other angle, then there's going to be no overlap because they're parallel. It's just like the sides of train tracks. And so if you say, where do they cross? They don't. And you could imagine exactly the same thing up here in the number line. You could say, what happens when x is bigger than 5 and x is less than -3? And no, it doesn't happen. So it's nothing unique about graphs that two statements don't always have a true solution together. Okay, there's a third case. So we could have 0 points of crossing. We could have 1 point of crossing. What's our third case?
It was a parabola.
No, we're only lines.
Oh,
No parabolas.
Can't lines only have one point of contact?
Yes and no.
Oh, and now, interesting.
yeah.
Got me.
Okay, so the answer is, well, what if they're actually the same line written in two different ways? Then the entire thing is overlap. And obviously, if it's something like x equals 3, right, this line here is, I'm sorry, y equals 3, the height is 3. It's pretty obvious. But it might be that you have other lines and it's not so obvious. Maybe your equation is something, come on, give me one to pivot. Slope of about 1/3, okay. So here we have y equals 1/3 x plus 1 excluded. I want to up cross right at 1. Okay. So why is this 1/3 x plus 1? Because if I look at rise over run, it's a 1 for rise and a 3 for run.
Hold on.
And then the y-intercept is 1, so that's this one here. And if you said also, I didn't realize it, but grab it. Okay, pretend these overlap. Maybe I wrote this also as y equals 2/6 x plus 1, and you didn't realize immediately that they were the same. So this is the kind of thing that might happen. Have I ever seen it happen in real life? No, but you can kind of understand where someone might not notice that two lines are actually the same. Okay, moving on. So the first way to see where two lines cross, where they overlap, where both lines are true, right? Those are all three different ways of saying the same thing, is what we just did. And let's do it forward and backwards to make sure I didn't confuse you. So grab the two lines over on the left, and two different people move them on. One of them should be y equals x minus 3. One of them should be y equals -x plus 7. Zoom in just a little bit for recording. Okay. I had them angled nicely, but that's okay, you can do it, you know.
Moving the whole box.
Isaiah's touchpad is acting up, maybe only the Zoom people can help him.
Oh no, my touchpad's fine.
No, it's me, that's,
And
That's all,
and
yeah.
his touchpad.
yeah, my lines are drunk right now.
Are you able to kind of do this, like, cause I can just tap and move. Instead of holding it, just tap it once and then try and move.
No, that makes me wanna type on the
Okay,
line.
that's too bad, cause it makes it so much easier. Or you can cut.
We need the green line to have a nice slope of 1. It should be a 45-degree line going up as we move to the positive axis. Should even sort of click into place on Miro and make
Oh,
a
yeah.
45-degree.
Yeah, you wanna try and move again?
Oh, dude, it's all you.
Medium all over? Oh no, just do the whole graph, yeah.
That way I don't look as bad.
I can walk the graph, walk. Walk. Okay, so where do these cross?
Uh,
5, 2.
2, 5, yeah, 2 fits.
So that's 5, 2. Does that work? Is it true that 2 equals 5 minus 3? And that 2 equals -5 plus 7? Yeah, that's where they're both true. Okay, everyone happy with that example? Now do the opposite direction. So here are 2 lines. They cross at 6, 9. Everything is good, don't touch the graph. But double click on the text box. And type out what these 2 graphs are. Or just call it out and make someone else type it, because there your secretary.
Oh, I got 6.
Everyone okay with x equals 6 being the blue line? We haven't looked at this kind of line before that just goes straight up and down like that.
Yeah, so it has no Y intercept.
Let me zoom in on mine. You don't have to zoom in on yours. What's the slope of the green line?
Pretty much 1.
And over 1, up 1, right? So it's just y equals x plus, and then what's the intercept?
3.
3, x plus 3. Okay, everyone happy with those problems? You could do things like that for homework if somebody asked you to.
I did before I showed up.
Okay, so when does that method work well? I'll take, you don't know. When. When would you want to take out your graph paper and draw the lines to see where they cross?
When we don't have like complete information, helps you save a lot of time on doing the actual math work. I know it's not really the right answer, but.
Hopefully you'll get good method equations by the time we're
Yeah.
done with this chapter that is not faster. So the practical answer is pretty much just never. This is good for, in theory, learning what happens. Only really. Let's see an answer if the point of overlap happens to have integer ordinates, so. It really only works, first of all, if the point where they cross is nice numbers, -3, 5. If it's not right on a point, and you have reason to believe it should be right on a point, then it doesn't even give you a precise answer. So this is really a method that we see now, so we theoretically in our heads understand what's happening, but this isn't how you go about doing this. So what are the strengths and weaknesses? Great for building intuition, understanding, but not accurate or fast. Okay. So what should we do instead? So the second method for these is to solve by substitution. There's a few different cases to look at. The simplest case is if they both say something like y equals already. So then I can say, hey, if they both equal y, then they both have to equal each other. So I can copy this part and say, wait, that equals y, then that's also going to equal x plus 7. Extra. Everyone okay with what I just did? We know they're the same because they're both the same as y. So how would I solve this now? Well, we've done this type of thing. I can say, oh, let's add an x to both sides, because who wants a negative x? Then I wind up with no x's on this side and a 7. And an x plus another x is 2x. That should be a -3. And then I will add 3 to both sides. And we get 10 equals 2x. And then it looks like I should divide by 2 to get x by itself. And we have x equals 5. Could you do all of this in fewer steps? Sure. At your first step, you could add x and 3 to both sides if you were that kind of person. But there's no virtue to minimizing the number of steps. Notice how I wrote things, my equal signs all lined up. Right, my x's all lined up. So I have some good technique of how I put them on paper. But how many steps I take isn't a good or bad issue. It's just whatever works for me. Everyone okay with that example?
Yeah.
Usually, it's not so nice. Just pick all of this up a little. So here we have x plus y is 7 and y is 2x plus 2. I can't just say they're both equal to the same thing already, like I could before. Well, one of them is just y is this stuff, right? Y equals 2x minus 2. So I could take the first equation, and wherever I see a y, I'll just get rid of that and put in the stuff that y equals. Everyone happy with so far? And again, now I know what to do. Let's see, x plus 2x is 3x. And then I'm going to add a 2 to both sides. And I get 3x equals 9. And so. Oh. Divide both sides by 3. And x equals 3. This is much more common. You'll have one of them have a place to say, oh, y already is a bunch of stuff. And so wherever I see a y in the other one, I'll just stick it there. It also could be true that neither of them is quite so simple to start with, but with a little bit of work, we can make that happen. So the blue equation on the top doesn't have x or y by itself. The green equation now doesn't have x or y by itself. But all I have to do is move the 3y and the 1 to the other side of the blue equation, and x is by itself. So you kind of stare at them and you say, what's the laziest thing I can do? What's the minimal work to get one letter by itself somewhere? And once you have that, then you can plug it into wherever you see that letter in the other equation. That was a lot of words. Let me not do it.
Visualize.
So we can say in blue that x equals not, oops, not x plus 1 minus 3y equals 0, but we're going to take away 1 and add the 3y to both sides. And we get x equals minus 1 plus 3y. Then I take that and I go into the green equation, and wherever I see an x, I put that. So we make that big so thick. I have negative 3y, no x's yet, equals, so far so good, 4 minus 2. And then whenever I see an x, I will put that blue stuff. Minus 1 plus 3y. Everyone okay just with that step? That's the key step. All other if I just lost. Okay, now it's the one time you get in trouble if you haven't done homework before. How do we multiply negative 2 by these things? I want to say negative 2, well, that's not visible. Negative 2 goes with a negative 1, and negative 2 goes with a positive 3y. So what I'm going to wind up with is negative 3y equals 4 minus negative times negative is positive 2, negative times positive is minus 6y. Now I will add 6y to both sides of the equation. These 6y's cancel out, negative and positive. On this side, if you owe somebody 3y's and they give you 6, how many do you really have? 3. 3. And 4 plus 2 is 6. Divide both sides by 3. And y is 1/2. Now, I have neglected something very important because I have not actually finished these problems. In the 3 things I just did, I only solved for one of the letters. I wanted to focus on the new thing. So I purposefully skipped over that, but realized I'm so far scoring 0 points on the test. If I have on the first one, x equals 5, then I need to go find out what y is. How would I do that?
Well, now that you have the value for x, you can plug that into one of those equations.
Yeah, does it matter which one?
No,
No, it's gonna be true for both of them. And just to test it, 5 minus 3 is 2. And negative 5 plus 7 is 2. This is the same kind of one we did up above, right? So That's the easy part, so I didn't want to emphasize it first, but just remember, you're not done. Until you have both. X and Y. And this one. We got X, so then find Y. Three. Plus 4 is 7. We'll plug it in twice, 3 is 6, minus 2 is also 4. For here, then find X. This might seem a little backwards. Normally, we plug in a number into X and get Y, but we can do the same thing. So X plus 1 minus 3Y. So X plus 1 minus 3 times 1/2, because Y is 1/2. Equals 0. So X plus 1 minus 3/2. So that would be X plus, and so X minus 1/2. Equals 0, so X equals 1/2. Adding 1/2 to both sides. Now I'm finding that. Okay, can people do more of these if you had to on homework? If you're in Zoom, give me a thumbs up or say something. Okay, nod your head. The trickiest part of these is this bit here, negative signs. When you plug things in and it negates it as you plug it in, it's sort of like it's trying to pull the rug out from under you. So pay attention to the negative signs. That's where the careless mistakes will happen. Okay, when did this method work well?
The whole time.
Yeah, kind of any time, but it's slow. So what are the strengths and weaknesses? Lots of arithmetic. Um, it works, okay. If you are ever feeling like your brain is being taxed because you're taking the GED and it's a time test and you're panicking, this is a great thing to do. It'll just always work. You don't have to test, does some other method work better? Just do this, it works, you're fine. But there is one more method because mathematicians like things that are cute and clever. So method 3 is called the elimination method. If I take the same problem we just did, I could line it up and say, hey, the blue equation has a negative 3y, and the green equation has a positive 3y. And that really makes me want to draw this giant black line with a plus sign under it. And if I add them up, those are going to cancel out. Just like adding -3 and +3. It doesn't matter that I'm counting by a y. I could count by 2s, 2, 4, 6, 8. I can count by 5s, 5, 10, 15, 20. If I count by y's, they're still going to cancel out. So if I add all of that up, then, well, x plus 1, the y's cancel out, 4 minus 2x. I think I want to add 2x to both sides. While I'm at it, maybe I'll subtract 1 to both sides. -2x plus 2x, that goes away. 4 minus 1 is 3. X plus 2x is 3x. Did I copy them wrong, or am I getting a different answer? No one called me out on a math error before. I must have messed up somewhere above, because I don't think I messed up here. Where did I mess up? Got to check my word, nothing else. So 1 + 1 minus 3y equals 4 minus 2 times 1. 3y
Is it your answer, was the y actually be 1/2 or 2?
2/3. I have a 1/2 and now it's a 2/3, so something didn't line up. Does that work in the blue? If I have 1 + 1 is 2. Yeah, so that works, so that's the right one, so y should be 2/3. Help me be a detective, where did I do this? -3y equals 4 minus 2 1 plus +2, that's -6 1.
Somebody was trying to say something.
Well,
why did
no, 6 divided by 3 should just be 2, why did I say? 1/2, I was confused there, but that's still not. That changes, that changes. X plus 1 minus 6 is x minus 5. That's really bizarre. 5 plus 1 minus 6 works. 4 minus 10. And okay, something. Plus 1 minus 3. Oh, because I changed it, they're not supposed to match. This one has a -3y, not a +3y. So I did make a mistake and fix it, but it wasn't for the reason I thought. Okay, anyway,
Hi, yeah. 2 divided by 3, yes. So,
okay, so. So that's not too bad. And add things up, the 3y's canceled out. Forget my big distraction of not realizing the green equation was actually different than the one before. So if you can have things cancel out by stacking them on top of each other and adding them, it's usually faster than the previous. That's the moral of the story. Sometimes it's not immediately obvious how to make things cancel. In this one, if I just multiply everything by 2. 2x minus 2y is -4. Now when I add them, it will work. 3x is 16 minus 4 is 12. So divide both sides by 3. Then I need to find y,
Wait, why did you put the 2 in front of those variables?
because I wanted these to cancel out.
So we multiplied everything by 2.
Before the bottom only had one y, and that wouldn't have canceled out when I added. Since the top has two y, I need the bottom to have two. I could also tangentially have taken the one of them and negated everything. And then the x on top and the x on the bottom, one would be positive and one would be negative, and those would have canceled out and I'd deal with y's.
So could you have solved it without multiplying one of those by a number? Like,
Using the method above,
yeah,
right?
you
Using
still
the
could
longer
have solved that way too?
Yeah.
Okay,
I could say x is 16 minus 2y, and then in the other equation, wherever I see an x, let's put in 16 minus 2y.
okay, yeah.
Oops. Lost it. Okay, then find y, 4 plus 2y. 16. Okay. So it's a cute trick, if you can see some way to make things line up nicely and cancel out when you add them, then it'll save you a little bit of time. But if you don't see it right away, by the time you fuss with it enough to make it happen, you might as well just use the previous method. Isolated one y or x somewhere, and then plug that in.
Yeah, I think that's the method I'm more familiar or comfortable with. Which probably takes the longest, so.
It's fine, just this is a tool.
So when does this method work well?
When you notice it.
And when you notice quickly that the canceling will happen. What are the strengths and weaknesses of the method?
Faster,
It's the fastest.
but doesn't always work.
Okay. So I could do more of these examples, but let's just move on to word problems. And we'll do more of them within the word problems. Okay, so we could use text boxes to type out the equations, or you could just say them out loud and I will be your scribe. Maria's cousin enjoyed visiting little Maria. The cousin is 5 times Maria's age plus 2 years. The sum of their ages is 20. How old are these people?
So
By
say a times 5 plus 2 equals 20.
Okay, first of all, I'm not gonna use x's and y's. If I use x's and y's, I'm gonna make some careless mistake because my brain is panicking because I'm taking a GED test. And
That's-
I'm gonna forget who's x and who's y,
That's why I
right?
said
So I'm
A.
gonna say something like Maria's age times 5 plus 2 more years is cousin. I'm gonna use M and C, so I don't have to risk messing up who is x and who is y.
Some of their age is 20.
Yeah, so it's gonna be like your check. Make sure you get that first.
So M plus C is 20. Okay, tell me what to do.
Well. M times 5 is 5m.
I could rewrite times 5 as 5m.
Normally I use X. So
Tell me.
normally I use X. So I think if we use X, it's easy then use M and C because some people will confuse about the math.
Okay,
With
you
the
can
letter.
certainly use x. No one is gonna yell at you for using x.
Yeah, 2X.
So. Do we have an easy substitution method? Do we have any letters by themselves?
C.
C. So I could take this top equation And wherever I see a C, I'll put in a 5M plus 2 in the others. That makes sense? So into the C, I'm going to replace with 5M plus 2. So then what do I get? I get 1 moment. If I started with capitals, I should be consistent. Okay. So I get M plus, and I'm looking at a C, so I'm gonna write a 5M plus 2 instead. Equals 20. Everyone with me so far? So M plus 5M, now I have 6 of those M's. And I'm gonna take away 2 from both sides. So 6M is 18. Six times 3 is 18. They're word problems. So 3 years is Maria. So how old is the cousin?
And then you plug that in.
I mean, you could probably just see a subtraction, so that was whole age.
Yeah, they add up to 20. I
Yes,
see.
it's 17.
So 17 years for a cousin. Everyone okay with that word problem? Great at terrible cocktail parties, otherwise when in real life does anyone ever give you these kinds of things? But maybe it would be on the GED, this is a kind of GED style question. Okay. Maybe slightly more practical if we look at money. Now Maria has dimes and nickels. Being a 3-year-old, she's excited, she has a whole $1.70 worth of coins. And there's 22 coins there. How many of each kind does she have? So first we have to decide, are we gonna write this in terms of cents or dollars? Either can work.
Cents would be easier, just because then there's not the decimal.
Okay, yeah, who wants decimals, cents? Okay, I like that vote, let's do that. So each nickel is worth 5. So 5 times how many nickels she has. Plus 10 times how many dimes she has. Is worth 170 cents. If I did pick to do this in terms of dollars, then I would have 0.05, 0.1, and 1.7. And it would still work,
Yeah,
but yeah, why?
See, I'll take decimals over fractions any day.
And
oh, yeah, with fraction, sure, but whole numbers are decimals.
and again, I'm using N and D for nickels and dimes, but
Small.
Sumsa can use X and Y because she likes X and Y. There's no right or wrong letters you could pick. Okay, and what's my other equation? What piece of information haven't I used from the word problem?
The 22 coins.
Yeah, so however many nickels I have, plus however many dimes I have, is 22. I don't have any letter all by itself already. What's the easiest way to do that to get started?
You pick which one you wanna get by itself first.
Sure, which
Let's solve
one?
for that. We'll start with dimes.
Okay, you want dimes by itself. So this bottom equation is pretty simple. How do I get dimes by itself by fussing with it?
And you just like subtract the n.
Yeah, so let's take away n from both sides. And I get dimes equals 22 minus how many nickels? Then I go back up to the top. And wherever I see a dime, I can plug in 22 minus n. Everyone with me? So 5n. Plus 10 times 22 minus n. Equals 170. So 5n plus, now I have to do my distribute. Positive 10, positive 22, that becomes 220. Positive 10 and negative n, they multiply and I get minus 10n. If I have 5n and I take away 10n, now I'm at negative 5n's. If I have 170 and I take away 220 from both sides, now I'm at negative 50. Everyone okay with, did I make any math mistakes this time?
Looks right.
It's correct.
Okay, 5n is negative 50, let's divide by negative 5 on both sides. And n is 10. So nickels. It's 10, dimes, well, they add up to 22, so it has to be 12. Questions about that word problem? Notice how I wrote things to kind of show my flow, including this very unofficial math symbol of a double-tailed arrow. That's like transition, like next step over here, but it's not next step in like the right one step below the next step, kind of next step. This is a shift of thought. Let's move over on the paper, try and keep things clear. You don't have to write it exactly in the style I do, but steal from what I am doing. Make things clear when you're having just a step in a math problem versus, oh, a whole shift of stuff happening. Now we're plugging one equation into another. Okay, it's almost 7. This is the last of the prepared things on the whiteboard. Let's see, nothing more. So we're pretty much done with the intro to this topic. We can talk more about it. I will just bring up the nice textbook and you pick problems and we do them. Or we could say, I think this is okay, and try the quiz all together, work together on those problems. It's about the same. But I'm asking because it is 7, Kayla's here, it's her kid's bedtime. Do you want to take a little break before we do this one? Maybe do some textbook problems if you don't need the bathroom and let Kayla put her little one, or does Kayla want to get this done and finish while we're on a roll, and then she will disappear and put kid to bed? Anyone have a preference, break or now? Break now or later?
We can do this problem and then go.
Yeah, you can do the problem, take a break, finish off the whiteboard.
Yeah, that's fine.
Okay, so one more problem and then we'll take a break. A chemist wants 12 milliliters of a 30% alcohol solution. Okay, for some reason they need that. But the stockroom doesn't have 30%, it just has 20 or 50. So how much should those mix together? 30 isn't halfway between 20 and 50. So we can't just mix them half and half. We have to kind of figure out the right proportion. Okay, I need 2 equations. What should I write? Should I use X's and Y's this time to make Sumsuk happy? Sure. No. I need letters for things. Maybe I can be, say, 20%, I'll use a T, and 50% I'll use an F. That makes sense to my
Yeah,
brain,
28,
maybe that
yeah.
doesn't make sense to your brain. Use X's and Y's if you want. If you use X's and Y's, then start at the top by saying, let X equals how many milligrams or milliliters of the 20% solution, and let Y and so on, so you know what's happening and you remember at the end. But I'm just gonna say that T will be that. Then we'll have F. The 50%. Okay. Okay, what are my equations? How about the first line? If I put them together, I need 12 milliliters. Don't think too hard about this.
So just 12 equals,
12 equals what?
um. Yeah, I guess 30%.
No, I just want T's and F's and maybe some coefficients. Some numbers multiplied by it.
Oh, well, F minus T.
Not minus, just I take the 20%, however much that is, I take the 50%, however much that is. Remember that the T's and F's are how many milliliters, what I fill it up to on the volume. So when I fill it up together and I mix them, it needs to be 12.
Yeah, I was misreading the top line.
Then the second line,
Yes.
this is the tricky
Yes.
one. This is gonna be like nickels and dimes on the top, 5 cents for a nickel, 10 cents for a dime.
Yeah.
But it's not as intuitive because we aren't chemists as much as we play with change in real life. So it's very much the same. I'm just saying that if I have 20%, oops, color right me. So 20%, 0.2. 20% of how much alcohol I'm using in the 20% solution, so that's T. And then I'm going to add to it 50%. Of how much of the 50% solution. Now, that's not 12. That's 30% of 12. The whole solution. Is going to be 30% alcohol, so that's 30% of the 12 milliliters. This is the most confusing thing we've done yet tonight. Questions about this bottom line? Want me to explain it with different words? No one's asking questions, okay.
So now we just
Solve, right?
solve for one
Yeah,
of them.
that was the
and
hard
Plug it in.
That one line was the hard part, now we're just plugging things in.
Let's start with that.
By the way, if you are allergic to decimals, let's just do a little tangent here, 0.2T. Plus 0.5 F. Equals 0.3 times 12. Now notice, if I'm doing a good job, either on the left or the right, when you look at this, you can read which are the decimal point dots and which is the multiplication dot. Because that dot is a multiply dot. If you don't have the handwriting habits to make it very clear. Then use X's for multiplying or be very careful.
Well, a parentheses would be,
You could use parentheses if you want. If I want to just scoot all of these dots over by one to get rid of them, that would make my life easier. Am I allowed to do that?
as long as you put them back at the end.
I don't even need to do that. This is just multiplying both sides of the equation by 10. And I'm allowed to do that.
Oh, yeah, just we can get 12 or square 120.
So I could rewrite that equation that admittedly isn't too bad, but it does look a little unpleasant, and most of the unpleasantness is because of the decimal points. I can rewrite it as 2t plus 5f equals 3 times 12. Do I multiply the 12 by 10 also? No, because this is one term. Remember terms from 2 weeks ago, 3 weeks ago? So if I multiply the term by 10, I've already multiplied it by 10. I don't multiply it by 10 twice. That's not fair. So multiply each term by 10 only once. Okay, or this becomes 2t plus 5f equals 3 times 12 is 36. So that seems a lot friendlier. Okay, so that's one equation, 2t plus 5f is 36. We still have 12 is t plus f. What should I do?
You pick one of them to get by themselves and
Okay, what do you want to do for that?
do, let's get the T by itself.
Okay, so I'm gonna start with this one and switch it to t is 12 minus f. Everyone okay with that? I subtracted f from both sides to get the t by itself. I could have gotten the f by itself. It doesn't matter, just pick one and do it. Then I'm gonna take that and bring it down and stick it to that t. So I get 2 times 12 minus f plus 5 more f's is 36. Now I'm going to distribute 2 times 12 and 2 times negative f. So 24 minus 2 of the f's plus 5 f's is 36. 24, if I have a debt of 2 f's and I get 5 more, I'm positive by 3. I can subtract 24 from both sides. So 3f equals 12. 5 by 3, and f is 4. 4 what? Who remembers what we're looking for? Way back at the beginning.
Or 50%. 4 millimeters.
4 milliliters of 50% solution. There, well, they had to add up to 12. So 8 milliliters of the 30%.
20 solution. 20%.
It was 30, right? The other
No,
one
it's 20.
The 30 was the.
30 was the goal, 20%, okay. See, I don't, okay. T for plenty, yeah. Okay, let's take a little break. Stretch, get your blood sugar back, raid my office for lollipops or protein bars. put kids to bed. We'll see you at 7:20, it's at 7:10 now. Okay, experiment time. We have done the two equations at once topic. Again, not as deep as we could have because of being pressed for time. But we saw a little bit of everything. And at least one example problem of the kind of annoying logic puzzles with the kids' ages, of the money and the mixtures. And on the GED, those are kind of the three types of things to think about for the word problems. So, ta-da, there we are. So I have now put into Moodle that you can see your grade books. And I have made visible quizzes that Julie made. This is more stuff I inherited, not that I made. I haven't ever clicked on these quiz links to see what will happen, but we're going to do the second one together of two linear equations at once. We're not going to use it as a assess your knowledge quiz. Your homework will tell me if you're getting things right or not. The point of this is to talk to each other, use the whiteboard more, and practice you writing things in nice lines, whether it's with the pen tool or with just text boxes, because all of this you can just do with text boxes. So if someone wants to, you can click on the grades, which you should now see up at the top. I'm gonna just peek over people's shoulders and see if you get a badly formatted mess, or if when you try and click on your own grade book, it looks like something good.
I already went into the quiz.
Quiz and patience is a virtue.
As long as those two, just please.
If you click on grades, see
What
grades
grades
at the
look
top. Does that look like useful stuff?
Yep.
And can you see details of like which homeworks you've done and stuff, or is it not?
No, it only shows this. Oh, yeah, optional practice quiz. It does.
It does. But it looks like only the ones that have been assigned, which is a tremendous number of them, but not nearly as bad. Okay. Optional practice total, that's a bizarre category. I have no idea why it's calling it that. Okay. But for the stuff that's there, you can see what you've done. Okay, so that's worth leaving up.
Yeah.
Okay,
Yeah, actually,
now,
at the beginning when I was mentioning, that's actually all I would need is a printout of that for my HR.
Oh, you're good that.
Yeah,
okay, that works. Okay, two linear equations at once. Attempt quiz, I'm a student, so I don't get that. Now, if you attempt a quiz, do you see all the problems or one at a time for a quiz? It looks like you get to see all of them. And like that, okay. So my job is to make this as cooperative as possible. Are we all seeing the same numbers, or does your quiz have random numbers that are
Same
different
thing.
than mine?
they're the same.
They're the same, okay, that's good, and that means I can say. Let's zoom out in the whiteboard. And. Grab the big yellow thing. Say quiz time at the bottom. Quiz number 2. And I can do things for you like. Everyone know shift window key and. S for take a rectangle screenshot.
I have a Chromebook, so I don't have a window, but
It'll be shift and then the command key. So I can put quiz problems on the board if that's faster than using a text box. But your job as a group isn't necessarily to fill out the quiz bubbles here, although you probably want to, because it's hard not to. but to talk together, use the whiteboard if necessary, and agree on answers. So I can keep recording the class if you want, or if you think putting this up on YouTube is gonna be embarrassing, I can stop recording, and the people that are absent today, if I'll have duties on them, they can do this by themselves.
It doesn't matter.
It's fine to keep recording, yeah.
Okay, if anyone wants me to stop, I will, but now I'm turning things over to you. You have almost half an hour till class is done. And if it takes us half an hour to do this, that's not a bad use of time. If we finish early, I have to figure out what else to do.
Make it take half an hour.
Alternative like 2.
Okay, so if you are in Zoom, we can hear you. If you want to show us something, then we can, I think on the D10, feature different people. Can we do that?
I just haven't figured.
You sort of speaker view.
Okay. So.
So
Pretty sure.
we could zoom in big enough to see a piece of paper, if you want to take a piece of paper and hold it up with tape. Or you could write on the whiteboard, because that's what it's for.
Well, now we can write down.
Yeah, I know.
Don't let Isaiah and Anthony hog all the work, because they're here in the room. Everyone can contribute except maybe Kayla, she's still putting some of it.
Alright, well. Order of operations, as we start with the parentheses, which there are enough, so you do the exponent first.
Let me know if you want the Zoom recording to be looking at the Moodle or the whiteboard, and I will switch back and forth. And I can be your scribe if you want me just to write something, tell me what to write, otherwise I'm not gonna write anything. You could also grab my stylus and pen and do that if you want. So windows are closed.
Yeah.
Have you been here when the windows get busted? No, part of being a good clean energy building is that the windows decide when they should be open, closed, and we can't control.
Oh, God.
This was a lot of fun during the summer when it was hot and there were fires, so the windows said, oh, it's hot outside, we should open ourselves.
You're right.
Wow.
So then you do multiplication, right?
So. Sure, but I'm seeing something like. That section's all the same. Doesn't matter.
Hey, Zoomy people, I'm not
I think this
hearing
is
or
a
seeing what
standard.
you're doing. How can I help you be participating?
Well, I feel like I got an answer for question 1.
I
Oh, okay.
feel like I have an answer for quiz number 2.
Okay, well then, tell other people, so maybe make a text box in
I thought that was only.
Miro and say, I think the answer is blah, something like that, right? So.
Oh, I put it into the meeting
Make
chat.
each other,
Someone put something.
Feel sick.
someone is saying
But
things in chat.
The 15,
It's what, 14.
15. I got 15.
Okay.
She's just spoiling it for everyone, calling out 15, yeah.
That's okay, we're not being very good team players, we're over here like whispering.
It's your first like group work of the term, week 4, you haven't had practice.
It's,
yet.
it's weird to do with like people on Zoom too and everything, not being sent here. It's possible.
Yeah, well, that's why we have the fancy whiteboard. Okay, yes, 5 + 2 + 8 is 15. Everyone is saying it right. For the sake of posterity, I will say that this is a term. That's a term. And that's a term. So the pluses will just continue going down. 5 is a very simple term that stays 5. 14 divided by 7 is 2. 2 times 4 becomes 8, and then 5 + 2 + 8 is 15. So, ta-da. you want me to put the next one on the whiteboard?
That's gonna be a long one.
Well, you can copy and paste.
That's true.
Yes, this would be in one you could, and you could put any of these on the whiteboard if you know this screen step secret. This looks pretty familiar. We just did these before break. So talk to each other, use text boxes, type out some equations. What letters do you want to use? All those things.
Well, I believe you should just use R and G for general engineering.
General mission tickets, user.
Okay, I don't want to do anything of my own initiative, but I did hear in this room, let R be the number of reserved tickets. And let G be the number of general tickets. So we have letters that at least some people have picked out.
Festival sold 4 times as many general tickets as reserved tickets. Each were sold.
Tell me what to write or type and they will. Or make it yourself, because you can do it.
Yeah, so one of the lines would probably be 25R plus 15G is 24,650. I think we should.
Can I take that?
Yeah.
So you said 25 Rs plus 15 Gs equals 24,650. Why did you say that?
Well, just kind of plugging in unknowns. And the 25 is just because of the amounts of money, then you have to multiply it afterwards anyways.
Okay. So each R is worth 25 bucks.
Yeah.
Each G is worth 15 bucks. And all of that money has to total.
That's the total out to.
Okay, that seems sensible.
So then
Okay,
the other equation is going to be, I think it's R plus 4G equals total tickets, or tickets sold.
Not quite. Would give us an extra unknown of total tickets. We don't want, so,
We don't have total ticket. Yeah.
yeah. How can I turn that 4 times as many sentence into something that's true without adding another letter of total tickets?
Four times G, four G. So that's why I don't know the total of the amount. So
15G times.
can you add more hint?
Okay, here's one guess that's wrong. 4 times the number of Gs is how many Rs there are.
One.
Does 4G equal R mean that we sold more Gs?
Yeah.
Or which is gonna be bigger?
So more Ds.
Oh, okay, I got it. So 4G equal 1R.
That's, yeah, so that's the trap. That's the one that's not right.
Yeah, okay, got it. Thank you.
Which is bigger in the word problem? How many generals were admissions were sold or how many reserved were sold?
Well, there was 4 times more general than the reserve.
Right, so there's more general.
Yeah.
Right? More people bought general than reserved, as you would expect at a concert.
Also would be equals that.
So it's not that four G's equals R, that would make G the small thing.
Right.
How do I fix that second equation to make it true?
G equals 4R.
Yeah, put the four on the other side.
Oh, really?
Does that, now do you see it? 4 times as many reserved tickets as how many general.
Okay, that makes sense. That's a bit of a-
Because for them to
mind-
equal
mind
together,
there.
otherwise it would be a less than a
Yeah,
greater.
it's a bit of a
greater
mind
than.
trap.
So that is the trap in this one, right? Now you have your 2 equations and this is gonna be an easy thing. Go ahead and substitute and solve. Okay. And wait till you get an answer and then work together, or you could tell people what your next step is, see if they're following the same steps you are.
Well, I just plugged in the 4R to where the G was and then just saw it from there. Like where the G was on the first
So
one.
this was now. Okay, you tell me, I'm not gonna rate something you're not saying out loud.
So it'd be 25R plus 15 times 4R equals 24,650, and then just solve that
Okay,
down to what I got at least was R equals 290.
That is what I just got.
so 15 times 4, 15, 30, 45, 60 are.
25R and 60R, 85R.
And
Then divide each side by 85. Oops, that one.
this come out even,
We get R equals 290.
290.
Yeah.
290 reserved. So which equation is going to be the easier one to use to get G?
I mean, if you don't mind dealing with big numbers, I honestly think just plugging in R is a little easier,
That's what I would have done.
like plugging in R to the first two. Oh. Oh, let's use the second.
Just do second equation, multiply by 4.
Yeah.
right?
Right.
So 290 times 4
Make myself way more work.
is.
So 1,160. So
Okay. So if everyone has this, pause and hold your papers up to the screen, because you haven't been writing on the on the whiteboard. I've been doing that. I want to go to gallery view. I wanna see that your equal signs are lining up. I wanna see that things look one step at a time, right? So show me your papers and then we can say, yeah, it doesn't have to look exactly like mine. No one will. And that's not like mine is the best way to write it, but the steps of flow should be the same on your paper, right? The equal signs line up. The
Man, that word from this work.
right, the numbers there line up. You have labels on your answers because it's a word problem. Michaela, Vincent, Dusty, and Victoria, show me your papers.
I do not have any paper.
Ah, okay.
I was just literally at all. I was trying to follow along and I guess learn how to break it down while all this was happening.
That's good. I mean, it's better than nothing, but it's sort of like watching someone do pottery, you know, until you get your hands on it, it's not gonna work as well. So, but better than nothing. Okay, yes, Kayla's busy with a kid to bedtime. Okay, let's move on to the next one then. People are sharing in chat. Uh, they're breaking into sound first. How many unknowns were in the problem? That we just did.
Oh, I was writing all the stuff that we just did all in one buck. Probably helps if I read.
Let's be
Like I
good
said,
and fill in the quiz.
it's
So how
okay.
many unknowns were there?
Two.
Two. We were tempted to make three, remember, there was this temptation to make a third one for total tickets, and we had to avoid that. Because this whole chapter is when you have an X and a Y, or some replacement letters, you don't have any Z's yet. Okay, define the variables, you can name them X and Y, we used the R and G, whatever you want. It wants you to go through that step. Write a sentence that summarizes the information. Blah, 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 and then what's your solution? Okay, so it looks like the next thing to actually talk about is number 6.
Like the time variables we were using.
What information does the equation y equals negative 12x plus 3 tell you about that line? You should list 2 things.
I don't understand the meaning of question. I don't got it.
I don't like this problem, how it's worded. I could list several things. They're giving us a line in slope-intercept form.
Was that
So I'm suspecting that the 2 things they are thinking about
still doing?
is the slope and the y-intercept.
I don't get something say.
So just staring at it, what's the slope with this equation of y equals negative 12x plus 3?
For me, I should be put if y equals 0.
Y equals which?
0, 0, 0.
0. If I
Yeah.
plug in 0, that would tell me where the x-intercept is. When the line has height, where does it cross the x-axis? I could do
So-
that. That might be a useful thing. There are lots of problems, like when does the ball finally hit the ground? Where you're looking for when y gets to 0. But that, we're not sure it's that kind of problem. Right, it could tell us though that yes, x-intercept is. Plug in y equals 0, 0. 0 equals negative 12x plus 3, so 12x equals 3, so x equals 1/4. So I could find the x-intercept. That is something this equation tells us. And again, it's not great how it's worded, because
I know, it's
one of
like-
the two things, maybe, yeah, I'm guessing they want slope and intercept, because they're giving us slope intercept one.
Like y-intercept?
The slope. Yeah. What's the slope? Just by looking at this, I don't have to do any math at all.
Minus 12,
Minus 12, and what's the y-intercept?
3.
0. Oh, 3,
Three.
3, yeah, you're right,
Mx
3.
plus. And y equals mx plus b, where the slope is the m. And the y-intercept is the b. But maybe what it's telling me is that this is a steep downward line. Now, if this is how much my investment account has, I should sell off my investments because it's tanking. Or something like that, right? A slope of negative 12, what does that mean in this situation? I'm not quite sure. So I don't like how this problem is written, I'm not quite sure
Exactly what it
what
means.
what two things they want. Because I'm a math teacher, I can make a guess that they want the slope and the y-intercept, but I'd rather they.
I know. Write down, give me slope intercept and
Okay, jargon, we never mentioned this jargon for number 7. There's different formats of a linear equation, all of those have x's, y's, multiplied by m sometimes. Put things in front of the x and y as coefficients, have some constant out there also. But the second one, mx plus b, that's slope intercept.
B.
it's a good industry standard for that, right?
That's the actual useful one. One of these is called standard form. Do you know which one it happens to be? I don't think we ever mentioned standard. Okay, well, go look it up so you get points for the quiz. Unless you go on Jeopardy, no one will ever care which one of these is called
Like
standard.
it looks like an ABC. I don't know.
Okay, explain how to graph 2x minus 4y equals 12. That's a great problem.
Okay, well, I'm still saying catch up.
One, and I maybe zoom in to grab it and make it bigger. Yes. So I want to graph that. Let's grab a. Way up. Way down. Two x minus 4y equals 12. So what steps should we do? Talk to each other. Actually, we're out of time, so if you need to go. We are done. It is 7:50. I'm not going to say try and get the quiz done by Thursday, because the middle of the week is usually not the best for everybody, but. By the time a week has gone by, right, so next Tuesday, try and get both of these quizzes done. As you see, they often are a little vague in how they're worded, like explain the steps you would use.
I know, it's such a.
And if you think it's better to just write out things on paper and use your phone, if you're a Zoomie, to take a picture of your paper and send that to me, then that works fine. You can say, no, I'm not going to list out a bunch of steps of how to graph
And
this.
we can do that, we can just write it down and
Yeah.
just bring it in.
And say, here are my steps, this is
That's
what I
gonna be
did.
way better.
I explained the steps you would go through, so write things down.
Well, I can't really put it in words.
I'm happy to spend some minutes reading homework quizzes, that's not a bad thing for a teacher to do. But again, the purpose of the quizzes is for me to see how you rate things, because the My Open Math tells me if you get them right or wrong. So. Yeah. Photos of papers are good. Okay, any other questions? Now, try more homework. If I was having a crowded week and I wasn't sure how much math time I could get before Thursday's class, what I would prioritize is going to the two linear equations at once. Looking in the textbook and say, in the nice textbook, it's section 7.1 to 7.4. See where I'm clicking? And then log in, holler at me if you don't remember the login. And this is exactly what we did today. And I would go through the example problems. And if they make sense to me, then I could click redo a similar one. And see if things make sense to you.
School gives you a similar instead of just solve this exact same one.
So that's a great thing to do, especially if you weren't able to physically write along. You need again to use your muscles to do math or it won't stick. So go through this and use the nice textbook, which has all of the videos. If you don't like the recording that we did, because it's hard to find where to go for things. And check how they have examples of the same things, what words they use. And if you do that, then I will trust that things won't have escaped your brain by Thursday. If you don't have time for anything, I'm a little worried that it makes sense now, but it won't make sense in a few days, because that's how math works. I'm wearing a Scotch bonnet. Okay, thank you, everybody.
Thank you.
Thank you.